So when we look at climate change outside of global warming, when we look at radiative forcing, CO2 equivalent, Earth energy imbalance, we're committed today to exceeding those tipping points. That's terrifying. It's the most dire of dire emergencies, and scientists should be screaming from the rooftops.
Hello, everyone, and welcome to the Climate Emergency Forum. My name is Regina, and I'm very happy to welcome you today as we discuss tipping points in the climate casino. Our discussion today is based on a paper recently released by the OECD discussing tipping points. We know that we have seen, as Paul likes to call it, weather weirding. I will say the last few weeks, the last few months, and the last few years, things have changed much more rapidly than even some of the less sanguine scientists had suspected they would do. Now, we've talked about the IPCC and the various reports that they, I won't say churn out, but they publish on a regular basis. And of course, these reports let us know how things are going along several different lines, including adaptation, mitigation, where we're at and where we can expect to be in terms of our goals. And one of the forum's criticisms of these reports is that, as dire as they are, and the last few of them have been quite dire, they really don't cover the full picture of what we can expect. A big part of this is the fact that they do not factor in tipping points. They do not factor in those unknown knowns that happen with climate change. One of these tipping points that is very, very grievously overlooked is the thawing of permafrost. We know that embedded within the permafrost are tiny, tiny bubbles of methane and all types of rotted matter. This material has been covered over a tremendously long period of time, frozen in time, literally frozen in time. And when this permafrost thaws, we have dangerous, quick-acting methane released into the atmosphere, which is a much more warming greenhouse gas than even carbon dioxide. Now, on the positive side, it doesn't last as long in the atmosphere as carbon dioxide, but of course, on the negative side, it produces much more and quicker extreme heat. And this is not factored in. Another thing that is not factored in with tipping points is the warming of the seas. And what this does, as the seas warm, they go underneath these layers of ice, of Arctic ice, and erode the underside of that ice and just releases that previously frozen water into the ocean, making many more changes. And of course, this can slowly over time account for sea level rise. All you need is a few millimeters for things to get really nasty for the world. And we've already seen this in many, many parts of our coastal cities around the world. So it's a very important thing to understand. It's important to realize that when we do get the news about how quickly things are happening, we're not hearing about these factors that make things much, much, much more pronounced. The warming warmer, the sea level rise rising faster, more thunderous storms, greater precipitation at a faster rate. To address the specific science of this, I'm going to turn it over to Paul. Paul, so can you give us some more details about the generalities that I've just expressed?
So thank you, Regina. So humans we're very linear thinkers, right? We look at trends and things changing over time and we expect them to continue. But the problem is that many systems in nature are highly nonlinear. think of lowering the temperature of water, and it stays water, and you can be a millionth of a degree above the freezing point and still have water. And then that temperature drops just a small, tiny amount, and you have ice. So you have a phase change from liquid to solid. It's a very abrupt change. It's a highly nonlinear process. And just think of tipping a canoe, right? If you rock a canoe back and forth, you reach this point eventually as you increase the amplitude of the rocking where things kind of seems to slow down, and you're on this precipice where the canoe either rights or it tips right over and you're in the water. So you reach this point of sort of no return or threshold level of the angle of tilt when you suddenly go over or you're in the water, you're in a totally different state. So, we talk about change in climate, mostly we think of it as linear, but then we get to things that are happening that are exponentially changing, right? You hear that phrase quite a bit. There's exponential increase in greenhouse gases, for example. Well, when you cross a threshold and cross a tipping point, it's even much faster change than exponential. There's a mathematical function called the Heaviside function. It's flat, and then there's a cliff, and then it reaches a new level and stabilizes. So we're talking about going from one state to another state in just a very, very rapid amount of time. And there's many elements of the climate system that will have that behavior. We're just not sure exactly where those thresholds will be. But as we soar past 1.5 Celsius, even before we reach 2 degrees Celsius, there's many of these systems that can actually flip and change states. And some of the most significant ones, most people are well aware of, say, for example, the glacier melt, right? You can reach a point where the glacier melt, you lose the ice shelves on the continent of Antarctica or Greenland, and then the glacier flow on the ice on the land greatly increases in movement and in calving into the ocean, and then you can get a total collapse. I think of some of the Larsen A, Larsen B, Larsen C ice shelves. One day they're there, a few weeks later, they were basically ice cubes in the ocean because the whole ice shelf just collapsed. Think of the Amazon rainforest. The conditions can be such that it's just too dry, too many years in a row. And then there's wildfires, which destroy large parts of the Amazon. And then because the climate is different, because it's much warmer and there's much less rainfall, then you will never get a replacement with forests and tropical forests. We can get just grasslands and savanna where there's the odd tree replacing the tropical rainforest. And it can happen very, very quickly relative to the slow change that we're used to. One of the biggest tipping points in the climate system that I see is the ocean currents, the AMOC, the Atlantic Meridional Overturning Circulation currents, because those connect with so many other parts of the planet. I call it sort of, the mother of all tipping points, if you like, because if there is a change in the ocean currents, a tipping, some shutdown, it affects everything around the planet. It affects the way heat is distributed between the poles. It affects the so-called rainfall belts around the equator, the intertropical convergence zone. Those shift towards the south. And that could basically reduce rainfall in Indian monsoons, for example, by 50%, which would then greatly adversely affect the ability to grow food and supply food in those places. So if you look at some of our biggest, most vulnerable areas, those are in our food supply and our water supply, our ability to grow food. And because of the way the jet stream goes around the planet, it can get stuck into these modes. We could have simultaneous crop failure through many of the grain growing, food producing regions of the world. They're all connected because of the jet stream configuration, or the mode of the jet stream, if you like. So these sort of things are approaching at ever faster rates as the global warming accelerates. And you can see right now, this summer has been extremely concerning in terms of the rates of increase of ocean temperatures, air temperatures around the world, and global temperatures. James Hansen is arguing that a lot of the increase is due to the reduction of aerosols. And I think he's spot on with those assessments.
Thank you for covering a lot of those, Paul. One of the things that I've heard is really, really close to a tipping point is that of the Greenland ice sheet. So what I've heard is that at 1.5 degrees Celsius, that this tipping point where the Greenland ice sheet could start to melt and never go back to what it was would be 1.5 degrees. And we're currently at 1.1. What do you think we can expect might happen with 0.4 degrees more warming with this perhaps melting of the Greenland ice sheet?
Yeah, the temperature has greatly accelerated its rate of rise since 2010. And by May of 2024, we will probably have experienced a full year above 1.5 degrees Celsius already. And in fact, by middle of next year, with the El Nino kicking in and all of these other factors, we're probably going to experience months at a time that are more like 1.8. So this idea of staying under 1.5 is absolutely absurd at this point, and we're rapidly heading to 2 degrees, and it's going to be extremely difficult to even stay under that. So I think it's all to do with the Earth energy imbalance. It's at record highs, and as long as the Earth energy imbalance is positive, then we're getting continued warming of the planet.
Wow, I can't even imagine. Just a few years ago, we were talking about how climate change would affect our children and grandchildren's life. And as we said in previous shows, this is not your child's global warming. This is our global warming. We are living it, and many, many people in other parts of the world have been living this reality for a very long time. And Peter, what are your thoughts on this particular topic? What are some of your insights?
Thanks, Regina. Yeah, I've been, of course, following the topic of tipping points for many, many years. And thanks, Regina, for mentioning that the science has been somewhat lacking in addressing and informing us on the real danger of tipping points, which I'll say a little bit more in a minute. Now, first of all, I want to acknowledge Tim Lenton, University of East Anglia. He's sort of our tipping point scientist now, and for some years, he really has been exceptionally good at trying to get across what we're risking with tipping points. So I thank him for that. But tipping points have been around for a long time. There was a really interesting research study done in 2009 by Potsdam Climate Institute, and they had the tipping point map that most of us are familiar with now. On that map, it's interesting, they had El Nino as a tipping point, by the way, more frequent El Ninos. So they did a survey of the scientists, and they came back with an answer that there's more than a 50% chance back in 2009 of major tipping points being exceeded if we carried on at the current rate of global warming. I emphasize rate because that's not emphasized enough, and it's just important, in fact, as the actual level of warming. Now, we have passed a major tipping point already, as James Hansen pointed out years ago, the Arctic sea ice. But what's far more important is that, as many of us know now, that we have feedback methane emissions from wetlands globally, peat-rich wetlands, and again, thanks, Regina, you've already mentioned that. And that's a tipping point because, as she pointed out, that these peat-rich wetlands all over the world, subarctic and tropical, contain vast, vast amounts of carbon. And they've tipped. They've warmed up enough now that both regions, subarctic and tropical, are pouring out methane. And hence we have, over the past couple of years, an explosive boost in atmospheric methane. And that is the most catastrophic situation that we face on the planet right now. And the expert Ewan Nesbitt has alerted us in no uncertain terms to that. So that's tipped. There have been a couple of recent papers saying so. University of Bremen published a paper last year, peatlands as tipping points. And in March also last year, there was an imminent loss of stability of permafrost peatlands in Europe and Western Siberia. These are really terrifying, terrifying papers. Now, we are committed have to say, and I've been trying to say this for many years, we're committed to exceeding many of these tipping points. Again, Regina's mentioned the 1.5 on Greenland. But government policy commits us to 3.2 degrees C warming. That's all the tipping points. Now, why can I say that's all the tipping points? Well, because in actual fact, the most important tipping point paper was the hothouse Earth paper, which was published by the late Stefan and a large number of other climate experts in 2018. That was actually a tipping point paper, multiple tipping points, 10 or 12. Now, in the supplement to that paper, every one of those tipping points is exceeded at 2 degrees C. 2 degrees C. We are committed by science, as Paul has indicated, already to 2 degrees C and more. And that's because we have a lot of inertia in the climate system, already being mentioned. And the scientists have been making a huge mistake from day one on this. The reason is we're using global warming as a metric for climate change. We know it's a very, very poor metric, and it's not the metric that we should be using. That metric is atmospheric greenhouse gas concentrations, which is the metric required by the 1992 United Nations Climate Convention. That's atmospheric CO2 equivalent, not global warming. Why is that so important? Because global warming doesn't tell us what the commitment is in the future. And it's the commitment to the future warming, which of course is vital with regards to tipping points, because we have to know when those are triggered. So if we were following climate change with CO2 equivalent, as we should be, then we would know that we were committing ourselves to exceeding those tipping points. Paul's already mentioned Earth energy imbalance. That's the other one that we should be using. And that's increased by a huge amount, like it's doubled over the past 10, 15 years. So when we look at climate change outside of global warming, when we look at radiative forcing, CO2 equivalent, Earth energy imbalance, we're committed today to exceeding those tipping points. That's terrifying. It's the most dire of dire emergencies, and scientists should be screaming from the rooftops that the IPCC AR6 told us that we had to put emissions into decline rapidly on an immediate basis. Why should be on rooftops? Because they haven't mentioned it. I haven't come across one scientist that's mentioned that we have to put emissions into decline on an immediate basis. Nothing proves that more than the fact that we're committed to multiple climate catastrophe tipping points. We have to act now, as indeed the scientists have been saying for the past 20 years.
Thank you, Peter. And I really do want to emphasize that once we cross those tipping points, that's it, right? It's a wrap. It's a done deal, people. You can't refreeze the Greenland ice sheet, the West Antarctic ice sheet. Once it's done, it's done. It's kind of like extinction. I think the United States took around 19 animals off the endangered list recently because they're extinct. So they're no longer endangered. Extinction is forever. Tipping points in terms of human scale, that's forever. And it also brings to mind, Paul, you being from Canada, of course, Peter too, there's so many things that exacerbate the situation. For example, I know that like the thawing in the boreal forest is something that we cannot have, but I'm wondering how much the wildfires that we saw last summer contributed to said thawing and what that may mean for tipping points.
I can certainly speak very briefly to the boreal forest. The boreal forest in Canada is still burning. They haven't stopped. We've lost 701,000 square miles. Boreal forest, the size of Washington State, and it's pouring out CO2. Thanks.
I've got my Paul Bunyan lumberjack shirt on today, so I'll just be going and chopping down some trees after we get off this call, as Paul Bunyan, up in Canada, hey, all these trees. Not. Yeah, that's a definite tipping point of the boreal system, right? The increase of hectares or square miles burned, and also the extent of the fire season. I mean, we started getting major wildfires in the boreal forest back in April and May of this year, and they're ongoing right now. They're continuing, and the acreage burned this year is at least an order of magnitude higher than anything we've experienced before, as is, I believe, similar in Siberia, in the boreal forest in Asia, which we don't have so much coverage on. But one of the big problems with fires in the far north on boreal forests is that many of these forests are underlain with permafrost, with very thick layers of frozen ground. So when you remove the trees above, the water can just percolate right down, and it's not just the warmth of the burning fires that could thaw the permafrost, but then it exposes them to more water percolating downwards, and then you get thawing of the ground, and then you can get loss of mechanical support, so you can get sinkholes collapsing in those regions, and it's all feedbacks which increase the amount of CO2 and methane in the atmosphere. So you get these, the concept of cascading tipping points is very important. When you get one major nonlinear event happen, the weakest part of the system, if you like, it could lead to a domino effect of having more and more tipping points being crossed. We need to use tipping points in human behavior to our advantage. We get enough people on the planet aware that this is a crisis, this is an emergency crisis, and maybe those people can have enough sway to force governments to take strong action to try to reduce the risk of these tipping points happening, to cut down, to slash fossil fuel emissions, and so on, to take things seriously, which they're not really doing at the moment. So the problem is that all the projections on temperatures and projections on economic impacts of climate change in the future, they don't treat tipping points as a serious risk. They treat tipping points as if they won't happen until 2100. Sort of thing. So it's interesting that the OECD came out with this report following up on some previous reports on climate and tipping points, because the OECD is not an alarmist organization. They're a pretty conservative organization. It's the Organization for Economic Cooperation and Development. And when these people start writing reports saying that things are a lot worse with climate because of tipping points, people need to sit up and take notice. Why are they doing it? Because they're very, very concerned about what's in the near-term future for humanity, basically, and it's going to hit their bottom line. It's going to destroy economies, it's going to destroy countries, it's going to cause huge geopolitical conflict. It's going to very likely lead to global food shortages and price spikes and, warring amongst nations. And we're seeing now the horrors of war, right? Not just in the Ukraine when Russia invaded, but in the Middle East as well. It's just horrific. And we've got to stop calling these things war. Like every time I see a banner saying Hamas, Israel war, it's not a war. I mean, one side has one of the most sophisticated militaries on the planet, funded by the most sophisticated military industrial complex in the US. And they have the ships and the aircraft and the weapons, the tanks, et cetera. The other side basically has nothing, none of that. And they're being bombed mercilessly right now. And, all kinds of international war crimes are being committed. And I still see the West as cheerleaders right now. So it's actually horrifying, but it's all part of, the climate system breakdown, if you like. We're seeing more and more extreme weather events around the world that are destroying infrastructure, cities, towns. Look at the stuff in Africa recently with the 2 dams failing and a coastal city being basically wiped out. I don't see all of these buildings and infrastructure being replaced as we move forward, because there won't be money, there won't be materials to replace them. So this is all part of civilization teetering on the edge and collapsing in various places. I call it death by 1,000 cuts. So tipping points is just another big factor in the equation. And there's many, many factors that we need to solve I just posted a video on 11 things that can basically cause civilization to collapse in the near term. So we need to kind of face up to what's happening and try to prepare as best we can for it, because governments are still funding fossil fuel companies at record high levels. So it's not going the right direction at the moment.
Thank you, Paul, for your thoughts on the tipping point and your thought on the tipping point of humanity, if you will. It feels like we've lost our collective minds. One would say it seems as though we've lost our humanity, but I would challenge one to think, what does that even mean? So with this deep thought, I would like for you, our audience, to let us know what you think. What do you think about the tipping points that we're discussing here? What are your thoughts about them? What do you think about humanity's ability to cope with them? Do you have any faith in our species? And with that deep thought, I'm going to hand it over to Peter.
Thanks. Yeah, I just want to stress again the boreal forest, because as Paul explained quite rightly, we have the entire boreal forest burning this summer, spectacularly in Canada, but also huge fires in Siberia, central Siberia, and eastern Siberia. So we've had the whole of the boreal burning. In Canada, it's still burning. We've got 657 active fires in Canada. That's less than 900. But the burned area is 71,000 square miles. 71,000 square miles of northern Canada has burnt, size of Washington state. A massive planetary catastrophic CO2 feedback, pouring out CO2. And this is a monumental catastrophe. I really don't think that's been recognized. As I say, Paul really stressed it and explained it, but it's not out there. This is a huge catastrophe for the planet, the boreal forest burning. And then we've got the peat-rich wetlands, as I say. They're emitting methane, a lot of methane, and all of them are emitting methane. So we are in the most dire trouble. It's way more than the emergency that we were thinking about in 2018. As Paul and Regina has indicated, civilization is in question today. Big question. And my God, who's doing anything, right? Paul mentioned the subsidies that the governments are giving the fossil fuel industry to keep burning up the planet, destroying the future, making the future a living hell for all the children in the world today. $7 trillion a year in subsidies today to the fossil fuel industry by our governments. Unbelievably terrible. So we've all got to get up there, and we're certainly doing our best, but we got to make a lot of noise, in order to get the attention of, everybody. We still don't have enough of anything like enough of the public involved. It's about the polls sort of internationally. It's about 65%. That's not enough. We've got to have most of the world up there demanding that our government stop subsidizing fossil fuels, make the switch to renewable energy, and then we can have the brightest possible future. But we're not looking at that today.
No, unfortunately, we're not looking at that today, Peter. And I always feel so not good when we close out on a negative note. We are not looking at it today. But I think and I believe that every little bit that we do on a personal level, in our actions with each other, do add up. I'm not going to say it's going to be world changing, but it does matter. The butterfly effect, if you will. One of the ways that I help myself in this time of environmental degradation and the degradation of our behavior is to really, really amp up positivity around people who I don't know, that I encounter on the subway, on the bus, on the sidewalk. You never know who you're going to affect, what change you can put out into the world, and it is absolutely worth doing, and it matters. And the fact that you're watching right now matters. We're very, very glad, as always, that you have joined us. If you haven't subscribed yet, and if you watched a few videos, why not go ahead and make that commitment? hit that subscribe button because we want to be able to be with you every week. And we look forward to seeing you next time with the Climate Emergency Forum.